Hey, welcome to the conclusion of an adventure in episode, scratch that, the conclusion of an adventure in old code. We were looking at Game.Bas, one of my brother's creations last time, and we were right in the middle of it. So let's fire it up and let's see what we get. We'll try and give it give it worthy attention and finish it today. So the last time we were talking about, so we got a single character from the keyboard, and that was POW string. We set that into POW string. If the ASCII code of it was 49, which is just the number 1, then we're going to do this. If the code is 2, then we're going to do this. And if the code is 3, then we're going to do this. So let's take each one of these cases in turn. Okay, if we've chosen 1, you recall that is the punch. Okay, we're going to clear the screen. Always clearing the screen. Well, actually, I was going to say it's probably better if you just erased the guys and put them back again so that we wouldn't have this blipping effect. But I mean, I guess you'd have to erase your input, erase the guys, update the guys. It's probably easier just to clear the screen. And that seems to be his preferred strategy. All right, so if we've chosen to punch, then we're going to clear the screen and put guy, but not guy this time, guy 1, which is him punching. All right, and then we're going to put at 300, 270 him. Okay, the bad guy. We have to put the bad guy back because we've cleared the screen. Then we're going to wait. And, oh yes, we came across this last time, and I think that's where I decided to stop. IT equals 75 minus accuracy. IT equals IT divided by accuracy. Hit equals FNR it. If hit equals 1, then his HP gets... Oh, yeah. Okay, so let's pretend my accuracy, I chose my accuracy as 25. Okay, IT, I'm not sure what that stands for, but that becomes 75 minus 25 equals 50. And if my accuracy, okay, so my accuracy in this theoretical scenario is 25, then IT gets divided by accuracy. So IT above was calculated at 50, accuracy was 25, and so that becomes 25. And then hit is a random number between 1 and 25. Huh? Maybe it's just a coincidence. We've determined if the accuracy was 25, then IT was 25. Maybe that's just a special case. Okay, let's figure out another scenario. Let's say our accuracy was 60. Okay, we're going to redo this as 60. 75 minus 60 is 15, and then IT equals 15 divided by accuracy equals 15 divided by 60. Huh? Okay, what is accurate? Oh, no, that's right. Accuracy is what you chose as your accuracy. So it's possible I chose 60 as my accuracy. And then this would come, this would be 75 minus 60, which is 15. And then we divide it by 60 again, which equals 0.25. And then we choose a random number between 1 and 0.25. Did he? Okay, I don't understand that. And the reason I don't understand it is because that's less than 1. And so you can't choose a random number between 1 and less than 1. It just won't work. Maybe I'm calculating this wrong. But in this case, it will never, ever, ever hit. So what we're going to do is we're going to set a breakpoint. And we haven't done this in Adventures in Old Code yet. But this is we can debug it properly. So what we're going to do is we're going to hit F9. And that is going to make that line bright red. The program will execute until it hits that line, and before it executes that line, it will break out and bring us back into this screen, and we can actually see the variables as they are in memory. And this is how debugging occurs, although the tools in these days are a lot nicer to use. But this is still a powerful debugging system in QBasic, and the fundamentals are the same. So we are going to choose 60 as my accuracy and punch as my punch and see what the heck happens. Okay, so actually let's not break there, let's break here. And I'm going to add a watch. A watch, instant watch, Shift F9. Okay, and I'm going to add, oh no, let's break, delete watch. Yes. Okay, we're going to add accuracy. We're going to add IT. And we're going to add hit. Okay, now as we run this program, when we break and we go into debug mode, these values are going to be updated with the actual values of the variables as they are in memory. And then we can step through the variables. So let's try this out. We're going to choose 60. Okay, so I guess my strength has to be 12. 60 accuracy and 3 hit points. Okay. And then I'm going to punch. Now it's broken out. Now you can see that up here, accuracy is 60, IT is 0, and hit is 0 because we haven't yet calculated that. So to step over is the F8 key, and we'll just step. That updates IT. And so yes, we can see that IT is 15, just as I calculated. Now we'll do it again. IT becomes 0.5. So hit becomes what? Okay, so hit becomes 1. Let's figure that out. So I did have it right. I'm going to delete all the watch. I'm going to clear all the breakpoints. And let's go up here. So X becomes 0.25. Okay, hold on. This is immensely frustrating to me. This is your random number generator, and then give me 10 values of FNR 0.25. Yes, syntax error. Oh, print the string value of this number. See, I know what I mean. The computer doesn't. 11111. Uh-huh. Okay, so RND will always be a number above 0. It's going to be between 0 and 1. When you multiply that by 0.25, you're going to get another number, smaller, but it's still going to be between 0 and 1. When you cast it to an integer, it will be 0. Then, so this will always, always, always be 0 when you throw 0.25 into it. Then you're going to add 1. So this is always going to be 1 if what you pass into it is less than 1. Okay? That's how the math works out. We can even go 100 and see all those ones. This, you're always going to get a hit. But once you pass 1 into it, 1 you'll always, if it's a little bit more, you can see that the odd time there are 2s, but still mostly 1s. So as the number you pass into this gets more and more larger than 1, more and more 2s will appear. So if I go 1.9, there are lots more 2s. I guess really all I need to do is like 25 of them. Okay, so there are more and more 2s, and once you get to, say, 5, there are a bunch of other numbers. Once you get over 2.1, then the 3s start showing themselves. See, there's a single 3 just below the middle of the screen there. And so what we're interested in is when this is 1, because that's what he's checked for. So it was a special case with 25. So this was 0.25. It will basically be 1 all the time because it's less than 1. And so if that random number was equal to 1, then the bad guy gets hit. If there's a bunch of numbers and, you know, they're all 1s and 2s and 3s, there will be less 1s in the possible numbers that you can get, and that is how you'll hit him less. So as IT increases, your chance of hitting him decreases. Okay, so this is the formula he's chosen. Very good. So what is the limit for your accuracy? IT divided by accuracy has to equal 1. So the difference between, if you're 37.5, halfway through the accuracy, at 37.5, that's when this will be 1. Anything less than 37.5, you'll get to miss. Okay, so that is the limit. So if you chose an accuracy of greater than 37.5, and because it's an integer, you have to choose 38 or higher, you'll always hit them when you punch. Well, that's good to know. Okay, anyway, if you hit the bad guy, then you subtract from his hit points a random number between 1 and your power, which is strong. And then you play this. We've seen this kind of before, his 20th note and his 50th note. All right. Okay, otherwise, if you chose 2, so this is the kick, then clearing the screen, you're going to put at x, y minus 20 this time, guy number 2. And guy 2 is the kicking motion. We put them up 20 pixels because just like in a different game, I think Quest, He's going to move up and kick the bad guy in the head. That's very nice. Put the bad guy where he always lives. And we'll wait. And this time, exactly the same. Ooh, not totally the same thing. This time we're subtracting half of accuracy, because remember the kick was half of the accuracy. That is what it's defined as. The accuracy of the kick is half the accuracy you chose. The punch was the accuracy you chose. The kick was half the accuracy you chose. All right. So in this case, if I chose 60 again, this would be 75 minus 30, which is 45. And then this becomes 45 divided by 30 is 45 divided by 30 equals 1.5. And because that's greater than 1, you could actually start missing. So this formula does work itself out. That's pretty cool. All right. And again, if hit is 1, then remove from his hit points. Instead of a random number between 1 and strong, this time it's a random number between 1 and strong times 2. So you have the opportunity to do more damage with a kick. And we're going to play this. This time we're playing A sharps and C sharps. All right, if we did our mysterious thing, then we're going to paint 0, 0, and 12. If you recall, the paint command, you specify a pixel and you give it a color. And if you don't supply a second color, it just paints the whole screen. And this is what we saw. When we hit 3, the whole screen went red. 75 minus accuracy divided by 3. Same formula, except now it's 3. Good thing I chose 60 as my example. This becomes 55. 75 minus 20. And then this becomes 55 divided by... Whew, another fly. Yeah, 60. Well, that's cool. That's 11/12. Pretty darn awesome. Okay, which is less than 1, so you'll always get it. So with an accuracy of 60, again, you're always going to hit on that powerful thing. That doesn't quite make any sense. Yes, it does. Okay. Yep. Okay, hit equals 1, and yeah, and ooh, this time instead of just simply strong times 3, you actually strong times 3 plus strong. That's just strong times 4. Okay, and then beep if it was successful, and then dir equals 1 to 1,000. I should put this back to what it was. All right, clearing the screen, putting you back to where you should be, putting him back to where he should be, sleeping. Then, if the bad guy's HP is greater than 1, he's still alive. Then we're going to choose a random number between 1 and 3 and call that bad. I'm guessing that's his moves. This is exactly analogous to your moves. So, what? Wait a second. If bad is not equal to 1, then him, then do the punching. If bad equals 1, oh, okay, so he doesn't have 3 options. He has 2. He kicks and he punches, or he throws his sword at you or whatever. 2 out of 3 times he will punch. The other 1 out of 3 times he will do his other thing. Very good, very good. Okay, and the damage it does is his strength for the punch, and the other attack is his strength times 2. We reduce your hit points, so that is the same thing, and we keep looping until either you're dead or he's dead. Okay, if you're the one who's alive, then points equal points plus 1. That's what we saw. If you're the one who's alive, oh, this is it. HP increases. Oh! Wow, your HP increases the absolute value of his hit points. Interesting. Divided by 12 plus 1. So essentially, if you killed him by getting him down to 0, just 0, then BHP is 0. The absolute value of that is 0. 0 divided by 12 is 0. And we're going to add 1 to 0, and so your HP is actually going to increase by a single point. Let's say he was at 1 hit point, and I just lambasted him, and I got him down to negative 50. Let's do negative 48. Then the absolute value of negative 48 is 48. Divide that by 12, which is 4, and add 1. So now my hit points is going to be 5, increased by 5. So 0, yes, you beat him, but it's really advantageous to really kick the snot out of him when he's down and get him to be as much negative as you can, because that will increase your hit points. Okay, and you keep looping until your hit points is less than 1, and at the very end you print points. So I went and added wait times to all these empty for loops. Let's do it. All right, we'll see now. I know that with let's say 12 strength, but with 60 hit points, or 60 accuracy, and my hit points are 3, from the formula I know I can do 3, and I should get him every time. Look at his hit points though, just 1. So my hit points are 3. So I'm pretty sure my mystery punch, or my mystery attack, will do anywhere from 1 to 48 damage to him. He's at 1, so if I can get a really good blow in, I should both kill him and my HP should skyrocket. So let's do it. Yeah, so I went up 3. So I must have had him down to minus 24. Because then we take the absolute value, divide it by 12, and then add 1. Right on. So that works. So the thing is, I can do my mysterious attack every time, and I'll hit him. Because I've chosen... Oh! But he beat me. See, with such a high accuracy, I have such low hit points, and he did damage. So, should I try again? Nah, this is getting kind of long, but I really like this concept. This is very cool. I think I did that last time. Boom, and I'm dead, because I had no hit points to begin with. But I'm allowed to choose no hit points. Okay, well this concludes this adventure in old code. This has been Game.Bas. We saw the game. This is game. Is there a game? Another game? Who knows? You never know what you get in adventures in old code. So have a nice day, and we'll see you next time.